Hi, welcome to video 8.1b, more integration review. This is from the book, example 3 in 8.1. Your first attempt would be to let u equal the denominator. That will not work. The derivative of that would be negative 6x to the fifth, and we don't have that. So we're looking at an inverse trig. We're looking at this denominator is square root of a squared minus u squared. If a squared is 16, then a is 4. If u squared is u to the sixth, then obviously u is x cubed. The derivative of u equals x cubed is du equals 3x squared dx. We do have x squared dx. We introduce the 3. We counteract with a third. And then we look at this as the square root of 4 squared minus u squared. This is our du. And this, of course, will be the inverse sine of u over a, which will be u over 4. And our u, don't forget, is x cubed. Just a reminder on your calculator, if you want to try some of the evens in the book and you want to know what the answers are, you use the template to do the integral. This is an indefinite integral. Keep in mind the calculator will not give you the plus c. Also, as a reminder of the first fundamental theorem of calculus, when evaluating definite integrals, you integrate and then you plug in the top number, plug in the bottom number, and subtract. Okay, this is example 2. It says select the correct antiderivative. In other words, find the antiderivative of this. This is, of course, a differential equation, so you're going to bring the x to the other side to separate the variables. And then over here, you let u equal the denominator. That makes du 2x dx. We have the x dx. Introduce the 2, counteract with a half. That gives you 1/2 integral du over u. When you integrate the integral of du over u, you get ln absolute value of u. U is x squared plus 1, which is always positive, so you don't need the absolute values. And then, of course, in multiple choice, they might use the power property, bring that 1/2 here to be an exponent, and then rewrite it with a radical. Number 18, the original question's in black. You let u equal the contents of the radical, and it actually works quite nicely. Derivatives 3t squared dt, and you've got the t squared dt, introduce the 3, counteract. You are now integrating u to the third. That'll give u to the 4/3 over 4/3, which is times 3/4. And of course the 1/3 is there. The 3's will cancel. Again, don't forget to replace u by t cubed minus 1. This you have to recognize as a dolly whenever the degree of the numerator is greater than or equal to the degree of the denominator. Then you have a dolly, you divide, there's your quotient, your remainder. So here's your quotient plus remainder over divisor. Integrate 4 dx, you get 4x. Pull out the 32, let u equal x minus 8 du is dx. You have 1 over u du, which is ln absolute value of u. This is a new strategy. If the numerator looks really complicated, as long as the denominator is a monomial, you can split it up. And that's exactly what we do here. So we replace this by x over the radical plus 3 over the radical. So two different integrals. Here you'll let u equal the denominator. Works very nicely. All we need to do is introduce a -2 and counteract with -1/2. And then when we integrate the 4 minus x squared to the -1/2, we get 4 minus x squared to the 1/2 over 1/2, which is times 2, which is where the half disappears to. Over here, inverse sine, pull out the 3. That's the square of 2. That's the square of x. Sure enough, du is dx. So arc sine of u over a, which is x over 2. Now we evaluate. We plug in the 1. Here we'll get root 3. Here we'll get 3 times arc sine of 1/2, which is 3 times pi over 6 or pi over 2. Plug in the 0. We'll get -2 to the half, -4 to the half, which is -2. And of course, arc sine of 0 is 0. 3 times 0 is 0. And if you were to do that on a calculator, you would get this answer right here of 1.839. Here, it's just a question of trial and error. If you let u equal the entire ln sine x, the derivative of ln is the thing over, 1 over this function times the derivative of this function, which is cos x dx, and of course that happens to be cotan, which is what we have. So this whole big ugly thing becomes the integral of u du. Integrate, you get u squared over 2 plus c, and then don't forget to replace the u.